All right, now we are going to get into some problems that are a little more complicated. Biggest difference will be we'll see when we set up our proportions, we're going to wind up having a quadratic when we simplify. So some practice with solving quadratic equations. Same process though. So remember the key idea is we have this altitude that we are constructing. Okay, so remember we construct an altitude from our right angle to that opposite side, creates these three different triangles. We know that all three triangles are similar. Okay, the whole diagram, the little triangle, and the bigger triangle. So the game is we need to get two sides from each of our triangles. Um, and then that's how you choose which two you want to use. We set up ratios for both. We set them equal to each other as proportion and solve. Okay, so if we look here, our smallest triangle, we have two sides for. We have a 5 centimeters and an X. So I'm going to redraw that. Looks like X, this side up here is a little shorter than the 5 centimeters. So I'm going to try to draw that and reflect that. Okay, so short, a little longer, connect, right angle, X, 5. Okay. Now I need to find another triangle that has two sides. I wouldn't want to pick the whole diagram because I have nothing along this side. I have nothing down here. So I'm going to have to use the bigger triangle that makes up the rest of the diagram. So I have this guy. Notice this one has a right angle here too. Okay. If you want to rewrite it, trying to turn it as you go, you can. I don't think you necessarily need to, as long as you can tell what the shortest side is, what the longer side is, and what the hypotenuse is. Okay, so we're going to draw that in. Okay, so shorter side, longer side, hypotenuse, right angle, short side is 5, longer side 6x minus 5. Okay, now we write out our ratio. Okay, so our shortest sides from each we have x and 5. Okay, so I can write that as x over 5 equals, then our longer sides, well, that would be the 5 from this triangle and the 6x minus 5 from this one. So 5 over 6x minus 5. Now we cross multiply. Okay, so x will get multiplied to the 6x minus 5 equals 5 times 5, 25. Okay, so now we solve. So x times 6x, 6x squared, x times negative 5 minus 5x equals 25. Okay. Hopefully we're seeing we got a trinomial here. We have an x squared, an x, and a number. So we need this set equal to 0 if we're going to solve this. So we should subtract 25 on both sides to get it equal to 0. So you have 6x squared minus 5x minus 25 equals 0. Okay. Now we're set up to factor. We don't have any like terms that we don't have a greatest common factor, so we go right to factoring. So if we're thinking here, 25 is the last number, so we don't have very many factors with that. So we're probably going to wind up with 5 and 5 or 25 and 1. That being said, if we have a small middle term, that leading coefficient with that being a 6x squared, we'd probably want that to be a 3x and a 2x. Remember, we always said try that first regardless. And then since 25 is a perfect square, why don't we try 5 and 5? We check it with our loops. Got 10x, got 15x. Great, we can make 10x and 15x become negative 5x. We would need a negative 15x, okay, and a positive 10x. Okay, so we needed that, be a plus here, minus there. Now we solve. Okay, so we have 3x plus 5 equals 0. Let's solve that out. 3x equals negative 5, x equals negative 5 over 3. Not good, right? Negative answer doesn't make sense. That's not going to work. Okay, remember, we know that because we look at our diagram, x as a side length, negative 5 over 3 centimeters doesn't make sense. Okay, so then we come and do the other one. 2x minus 5 equals 0. Solve that. 2x equals 5. Divide both sides by 2. X equals 5 over 2. Okay, so that would be our answer. If you want to throw some units on it, it said centimeters. Okay, so we could say 5 over 2 centimeters for the side length. Okay, but the value of x would be 5 over 2. Okay, let's do one more like that. Okay, so again, let's copy this down on page 96 on a blank page. Okay, so this one's another good problem type that's a little different than the last one. Same idea, we have an altitude constructed from our right angle to that opposite side. Okay, we have the three triangles formed. Remember, the game for how you're picking your triangles is you need two side lengths, whether that has an X or numbers in there. You can't have two of them being blank and use that triangle. So hopefully we're seeing this bigger triangle would be the one we'd want as a starting point. Okay, because we have the 4 and the 6 given. The right angle's right here. I like to just redraw that. So the 4 looks like it's longer than our other side here. So let's reflect that. Okay, so long side, short side, hypotenuse, right angle, 4, 6. All right, so now we got to find our other triangles. Again, we need two sides on there. So if we look at the small triangle, we have an x squared here, but we have nothing for these other two sides. That's not going to work. So we go to the whole diagram, and hopefully we see we have a 6 here, and we have numbers filled in along the bottom here. Okay, so we're going to have to use the whole diagram. The right angle's in that corner. So let's redraw that. So it looks like the 6 is a little bit longer than side SN over here. Okay, so the long side, short side, hypotenuse. Right angle, 6. Now you're probably thinking, what do I put along the hypotenuse? Because it's not just a single number. Well, it's made up of these two different parts. Okay, so we'd add those together. Well, 4 plus x squared, that's just 4 plus x squared. Okay, we can't combine those. Okay, so the side length would be 4 plus x squared. Okay. So now we have it set up where we have our similar triangles redrawn. Okay, sorry, I know it's a little messy. So now we can match things up. Okay, so we have the 4 was the long side. That matches with the 6 from over here. Okay, so I can say 4 over 6 equals, well then 6 is the hypotenuse here. That matches with 4 plus x squared over here. So 6 over 4 plus x squared. Okay, cross multiply. Okay, so we have 4 times 4 plus x squared equals 36. Okay, so now distribute 16 plus 4x squared equals 36. Subtract up. Here, notice how this one's different than the last one. We don't have a term with just an x, right? It's just an x squared and then a bunch of numbers. We really just have one term that has an x in there. So why don't we just solve by square roots, make it a little simpler. Okay, so we could subtract the 16 over. We have 4x squared equals 20. Divide by 4. Now I got x squared equals 5. Square root both sides. X equals, well, really it's plus or minus root 5. Again, if we look over here, our x is really just right here. So we have plus or minus isn't really going to change anything because we're squaring it either way. So you really could do either. Why don't we stick with the idea that when we're finding x's in here, if it's a real world diagram like this, it wouldn't really make sense to have the negative answer. So just root 5. Okay. Well, root 5 squared, if it just said what's the side length, that'd be 5. Okay. That's the basic gist of it. Nothing necessarily all that new from the other problems, just throwing in some applications with quadratics in there.